You have a nice introduction about me. This is Bharat Kumar, working as a principal engineer at Extant Solutions Private Limited. So earlier I was worked as a assistant professor at different places, and now later, recently, just 3 years back, I shifted to this particular IoT field. Okay, so without any delay, so further delay, let's start the session. Okay, let me share my screen over here. Okay. So are you able to see my screen?
Yes, sir. It's quite visible, sir.
Okay, that's fine. That's fine. So let me maximize it. Right. Slide mode. Yeah. So for with your permission, for bandwidth issues, I want to switch off my video over here.
Yeah, okay, sir. No problem.
Okay. Okay. Right. Right. So if any questions are there, definitely we'll meet again in the video meeting. Right. First of all, this is a very tough session for me because it's a post-lunch session. So it's very difficult to make the people to sit after the lunch. Okay. Of course, because I faced so many times like that. But anyhow, I will little bit introduce. The morning you have seen a good introduction about the introduction to IoT. So what are the different stages are in IoT? So that you have seen in the morning, like sir has given a good introduction about all the elements in the IoT. So just for a brief understanding of that, I will just give a few things over here. What are the important things in the IoT here? It is I don't want to do anything. Just I want to give what are the elements. So first elements are first and foremost very important elements are sensors. So where you are going to apply your IoT application. So first of all, you have to choose your sensors. Okay. Yeah. So first elements in your IoT is sensors. And after that, as you know that somebody asking that pre-processing. So somebody is finding out that pre-processing. What is this pre-processing here is that whenever you are choosing some sensors, how to read the information from the sensor. So you want to connect some sensor to the somewhere, means you want to read some information from the sensor. So how will you read that information from the sensor is going to be possible by connecting microcontrollers. So it may be any type of microcontroller nowadays. It's a kind of combination of controller plus processors. So like after ARM, it's very difficult to differentiate the controllers and processors, because again all the controllers also got the capabilities of processors, like in terms of memory, in terms of speed. So controllers are also too much increased. But anyhow, it's a controller or processor that we have to connect the sensors to this, and we will pre-process this data. That means we are going to receive some data from the sensors, and as well as we have to convert that data into a suitable digital format. So we have to convert so for that particular purpose we have to pre-process the sensor data. So for that we'll use the microcontrollers. So once, okay, in our IoT means internet. So without internet there is no meaning of IoT. Otherwise if you just remove the internet from the IoT, it becomes an embedded system only. So there is no internet if without without internet there is no IoT. So for that, to connect to internet, or rather to connect to any those things, we required a third element as a gateway. So we required a gateway over here. Sometimes what happen here, this gateway and microcontroller both are going to be available in a single device. So don't confuse with that, because sometimes the people may get the gateways are going to be combined with microcontrollers, like microcontroller and gateway both are combined, and that itself is called as a gateway device. Okay, but anyhow, the gateway is very important for us to connect to the any part of the internet. So from gateway to next we'll go for the third and foremost important part is here is the cloud. Okay, from gateway to will connect to the cloud, and once you connect it to the cloud, here we can do so many things like data processing. This is sensor processing, and whereas this is data processing, because you know that sensors are very sorry, microcontrollers are uh, it's not highly processing capabilities. So that what happened here, we to connect a sensor and to read the information from the sensor, we need not very high processors. We can go for a small controllers, and using that we can do some sensor processing over here. But with these sensors we are collecting a huge amount of data. Then how to segregate that data, how to eliminate the duplicates, how to um, uh, extract the information from that particular, sorry, how to extract the information from the data. So like this, there are so many processing techniques should be performed on the data. So that is going to be done by the clouds. So once it will perform the data, again it will give the result. For example, I have a data of last 30 days of temperature. So now I want to predict that what is the next day temperature. So like that, this 30 days temperature information we have to give to the cloud, so that cloud will do some analysis on the temperature values, and it will come up with some solution, and it will give that particular output to the, again back to the gateway, again the gateway to the microcontroller, again microcontroller to the, sorry, here it is not sensors, microcontroller to the, will go for the actuators. So there are some other people, other background than ECE. So actually I'm basically from a ECE background. So I may use so many of electronics terminology, but definitely I will try to explain what is the terminology that I'm using here. So what is actuators here is that whenever we are reading some information from the sensors, and if we want to activate some other things like for example, I want to read the temperature and I want to switch on the AC. So here temperature, reading the temperature is a sensor, whereas switching on your AC is a actuator. Here who will switch on your AC? Some relay will switch on your AC. So that relay will becomes a actuator. And I want to do one more thing, like whenever a person comes near to the door has to be open. So who is the sensor here? The person, the sensor which is recognizing the human being, that is a sensor here. And who is opening the door here? A motor. So the motor becomes a actuator here. So like that, sensors will sense the information, and controller will sorry, actuators will do the action. So like that, this will complete a cycle. So in this cycle, what is our topic here is, our topic here is the IoT protocols and standards. So where are these protocols will comes from here. So at the stage one, at this particular bottom stage, whenever we are connecting from sensor to the microcontroller, there are some protocols we have to follow. Those are called as hardware protocols. So the first one we are have to have is a hardware protocols, and then from microcontroller to gateway, we have to have network protocols, and from gateway to the cloud, again we should have to have something called application protocol. Of course, here again, from whenever you are connecting from the sensor to the microcontrollers, so sometimes this may be a wired protocols or wireless protocols. Okay, so we'll discuss about all these protocols. One is hardware protocols. What are the different hardware protocols we'll use in IoT, and what are the different wireless protocols we'll use, and what are the different network protocols and application protocols. This is my session. What I'm going to discuss is about all these protocols and standards. Okay, so let me start this. So what are standards? So as you know that for to work with anything, there should be some specific directions we have to follow. Otherwise, there should be some specific measurements we have to follow. So without standardization, if you try to do some uh, works, what happens here whenever it is comes to the real time, otherwise whenever it comes to the interoperability. What do you mean by interoperability? So whenever you want to, you developed one device without following any standards, okay, the some other people will develop some other device, they are also, they followed their own way of things, and I followed my own way of things. Now it is a time to interoperate from my device to other device. Is it possible? If we are not following any standards, is that possible to communicate with that? No. Why? Because you didn't follow your some standards, you followed your own specifications and they followed their own specifications. Then where is the standardization in this? So that we have to follow. So whenever you want to do some interoperability with the devices, and whenever you want to communicate to the particular clouds, means you have to follow particular protocols, so that all the other people also able to send these things to the, so that we can get the benefits by following the standards. Okay, so here standards are published documents like your IEEE. I think most of you people know about IEEE. So how IEEE will give all the standards like Bluetooth, Zigbee, all these are IEEE standards only. So Zigbee means it has to be work on the particular frequency only. Bluetooth means it has to be work on the particular uh, protocols only. So like that, we have to work on the particular standards. Okay, and these standards are fundamental building blocks for any product to developed, any product development, by establishing consistent protocols that can be universally understood and adopted. We should not follow our own protocol. We have to follow some protocols which are universally understood and universally adopted. So let's see that. So why we have to follow these standards? So what we discussed up to here is the same reasons. Like first one is interoperability. So whenever your device wants to work with other devices, definitely your product should be developed with some standards. So without following any standards, if you develop any application or any product or any service, you want to develop give any service, all these things are not possible if you are not following any standards. Similarly, interoperation across the physical communication systems and protocol syntax, data semantics, and domain information. Data semantics means like your frame structures. So you should have to follow some particular frame structure. If it is a I2C, you have to follow a particular frame structure. If it is a UART, you have to follow a particular frame structure. So like that, if it is a application protocol, you have to follow a particular frame structure. So like that, different communications will follow different particular standardizations. Okay, at the same time, we can go for the economy of scale. We can do mass production if all the people will particularly follow the particular standards. Definitely will produce the devices in a mass, like bulk scaling of the products will be increased over here. Okay, similarly, developers, regulators, and users, all these people are going to be get benefited. Why? Because those are following some standards, means everyone is having same kind of standards with them. Definitely that product is going to be have a multi-operable, so like that it is going to be communicate with any other devices, something like that. And also, if you follow certain standards, the people also give a particular security solutions for your product. If the people don't know what kind of standards you are following, how they will provide the security for you? Okay, so that is not possible to provide the security. So because of that, you should have to follow some certain standards, so that those people who can provide the security in the form of authentication keys, in the form of two-way filter or three-way filter securities. So like that, they will give you some kind of security if you follow the proper standards. Okay, so this is the IoT. Main things are like things means all devices. What are the devices which are going to be embedded with some sensors? Devices embedded with sensors plus microcontroller. Things means it's not a single one. sensors and microcontrollers. If we both combined together, then this becomes a thing. Okay, sensor plus microcontroller. If you combine both, then this becomes a thing. And the second one is data. That's what I'm saying, that whenever we are having things, means these things will generate so much of data. Okay, so then where you will store this data? This is going to be, data will be stored in the cloud. So because huge amount of data, things will generate uh, thousands of messages in a day, or lakhs of messages in a day. So where we have to store all this data, means we have to go and store it in a public clouds or whatever it is. But who will combine these two? The things and cloud, both are going to be combined by the internet. So that is going to becomes Internet of Things. Then, but if you want to make all these things interoperable, if you want to make this communication successful, definitely we have to add the fourth one here, that is processes and standards. So without adding this process and standards, I think you people are not able to do the particular proper communication. Okay, so let me wait. Yeah. So these are the different organizations that are going to be given the IoT standards. You people may ask that what are these names means. These are all the names which are going to be give some standards for the IoT. So IETF, I think this is very well known for the engineering people. Okay, Institute of Engineering and Task Force. Okay, and similarly All-Seen Alliance and OMG, that Object Management Group. This OMA is very famous for the mobile applications, that what are the mobile standards in IoT. So whenever IoT on mobiles is going to be done by these particular OMA standards, this is also one of the famous organization to give the IoT standards. And everyone know that Zigbee is one of these thing, and IOTA is one of the thing that it will give the standard architecture for the IoT. So this IOTA, we can call it as IoTA. So this IOTA is a one of the standard organization which will give a standard structure for the IoT. So like that, there is one more important thing is IPSO. So which will give that unique address for the IoT objects, IP for smart object. IPSO means IP for smart objects. So this is also why, because why we have to give a separate IP for the smart objects which are going to be available in the Internet of Things is because you know that IoT devices are very small. For example, I want to read a temperature. I didn't require much things on that. Only one sensor, one small microcontroller, and I will connect this to the gateway so that I can read the temperature information for every 1 hour. So that what happened here? But like this, you are not only the person in a world. There are crores of people doing this application. Then how to identify each and every small objects uniquely? Your IP address, you can say that, sir, we have an IP address. That IP address is not sufficient. IP addresses are not sufficient to identify your objects uniquely. So that this IPSO has given a solution for identifying your devices uniquely. So similarly, IEEE is also part of these particular standards, and IoT GSI is also part of the standards. Like that, so many people comes into picture to different standards at different stages. All these are not work for the complete levels, because we have different stages. We have a physical layer, we have a data link layer, we have a network layer, we have an application layer. So at different layers of IoT, so we different standards has to be come. So like this OMA, whatever that we discussed, like OMA and this IOTA, these things, these people will use the things at a application level. Similarly, this IETF, this IETF will give the standards at a physical layer and the data link layer. So like that, at different layers, different people works for the different things. Okay. Yeah, this is what earlier we discussed about that. There are 5 layers in the IoT. In the concept of, if you comes to the concept of IoT, there are 5 layers in the IoT here. One is sensors, that is we can call it as a perception layer, or simply we can call it as a sensors layer. Okay, at sensors layer, of course, in the perception layer, not only sensors, of course, your microcontrollers will also comes into this picture. Okay, so microcontrollers will comes into picture here, sensors plus microcontrollers. Okay, so this will sense and gather the information about the environment. Okay, once it gather the information, then second one is transport layer. How to transport this data to the other particular next layer. So the transfer the data, sensor data between the different layers through networks, such as it may be a wireless devices, it may be your 3G or 4G, or nowadays 5G also came. So 5G, or either it may be a Ethernet cable like your LAN. Using your LAN also we can send the information using Bluetooth, using RFID, using NFC, near field communication. So like that, we have so many things in a transport layer. Okay. Similarly, once all these things are sent to the cloud, so this is the next third one. Third stage is cloud. So here stores, analyzes, and processes huge amounts of data. So once again, I'm repeating here, the clouds are processing the data, not the sensors. Okay, why the controllers are here? Controllers are here to process the sensor data. And once sensors are processed and they will get the data, that data is going to be sent to the cloud. So for the cloud, we may get a huge amount of data. So that particular data is going to be processed by the clouds. Okay, so here we have different protocols. And next one is application layer. So once this is stored and all these things, then what is the results of this analysis? So the results of analysis is going to given by the application layer. So once application is ready, we have to do a business. We have to make it useful for the society. So until unless if whatever the application you developed, if it is not useful for the society, if you are not able to um, bring that particular application to the people, there is no usage of doing that. That's why here this last layer, business layer, is also very much important for the industry people. Okay, but for ourselves we can learn up to here. The first 3 layers is, sorry, first 4 layers we can go up to application layer, but again business layer is having a different perception. Okay, so these are the different layers that we can have in the IoT. Okay, so if you observe these particular protocol standards, you can easily see that at different stages we are having different things involved here. So here in the bottom, whatever we call it as a perception layer, so in the bottom we'll have the controllers, microcontrollers and microprocessors. So along with we are going to have some sensors. So these are going to be connected to the this particular cloud using, this is the gateway. So whatever the 2 things that are showing here, these are the gateway protocols, and which are connecting from sensor to the cloud. Okay, so gateway protocols are again I think most of you people know Wi-Fi very well, how to work with the Wi-Fi. That is, gateway is nothing but connecting to the internet. How we are connecting to the internet? We can connecting the internet through the Wi-Fi or through the Ethernet cable. Okay. Similarly, we can have a 802.15.4. Anyone can guess what is this 802.15.4? 802.15.4 is a IEEE standard which is going to give and represent the Zigbee protocol. So like we can use Zigbee, we can use Bluetooth, we can use 6LoWPAN. This is one of the networking protocol which is particularly used for IoT products only. So particularly used for IoT products. Why? Because IoT products are very lightweight. These are not complex things. That it's not like a complex system that is going to be used so many things. Here it is a very lightweight systems. So to address these things, we'll use a 6-LoWPAN networking protocol. It is again a version of IP version 6. We can call it as a simple modification to the IP version 6 to work with a low power devices. That is called 6-LoWPAN. So 6-LoWPAN is almost the same like IP version 6, but it is worked for the IoT devices. What do you mean by IoT devices? Low power devices. Okay, once that is finished, we'll have the cloud protocols like COAP and HTTP and all these things. Okay, so after these, along with all these things, there are some standards developed that is called OMA and IPSO and OCF. Of course, we have worked earlier with the OCF standards and all these things. Okay, but again, IPSO, OMA, all these, you may ask that who are all these things? These are all the people who follows the standards from physical layer to application layer. So they have given some standards so that that standards are going to be applicable for all the IoT devices. So they want to try to get some globalization, like overall the world. I want to use only particular standards only, so that what happen here, the uniqueness of the products will be that limitless of the products will be waived off, so that the products will be available globally, so that anyone can make use of that fruits of that particular product. So these are the different things. Of course, this is again same thing, but represented in a layer wise, at different layers, what the different protocols that we can have. So in this particular thing, I don't want to discuss each and everything of these particular protocols here, but I want to go further. These are the protocols that I'm going to discuss for this particular session. Okay. So what are the protocols that I'm going to discuss is, there are 4 types of protocols that in IoT I'm going to discuss now. One is hardware protocols. You may ask that what are all the things that you discussed up to here. See, up to here I discussed that what are the layers and standards that are available in IoT for at different stages. Okay, but now I want to go specifically few protocols which are majorly used in IoT. So those few protocols I will discuss little detail. Okay, I think you people understand. So now I want to discuss about the hardware protocols, and then I will go for the wireless protocols like Bluetooth, Zigbee, LoRa, and Sigfox. And next I will go for the network protocols, and then I will go for the application protocol. Okay, so before going to hardware protocols, let me have a quick question. How many of you are sleeping? How many of you are sleeping? No one say yes. Okay. But anyhow, just I want to take 1 or 2 few questions just for 1 or 2 minutes, and after that I'll come back to this particular hardware protocols. Of course, and these particular PPT will provide this PPT for you later also. Whenever you want, you can go through this particular PPT and all. But meanwhile, just I want to take 1 or 2 questions over here before entering into the hardware protocols, because I want to have some questions in the hardware protocols, especially for AC and CSC people. Okay, is there any questions? No questions?
Yes, continue, sir.
Okay, right.
I think all will discuss the question in the last, so they are not asking right now. So just
Okay,
take the question in the last, sir, please.
Yeah, okay, sir, that's fine. Okay, nice. So let's whatever the things that up to now we discussed is at different layers, what the different protocols that we are used, that we have seen that, because we are not go in particular to all those things, but now I want to go in particular to hardware protocols. So what do you mean by these hardware protocols here? Where we will use this? So we will use these hardware protocols to connect your sensor to the microcontroller. I think most of you people, I think it is ECE and might be CSC. One subject is there, microprocessors and microcontrollers. So I'm the person who completely hate this subject in my BTech, completely, because it was a very toughest subject for me, even when I'm reading my particular BTech. So whenever it was there, I used to by heart all the pin numbers, all the protocols, that whatever there, and whatever they are explaining, even what is that that logical high, logical low, timing diagrams. So it's going to be a big confusion while I'm in BTech, and still that particular things will be continue for the few people. So okay, so particular controllers, particular sensors, particular wires means, oh, it's very dangerous one. But it is not like that. Now what, for the God's sake, again, God must be crazy, I think. That's why he made me to learn all these hardware protocols and software protocols. Especially I hate these things, but now I'm working on the complete embedded system only. Okay, but anyhow, we'll discuss that here in the hardware protocols. What are the things that we are used to connect the sensor to the microcontroller? So let me go for the first one, that is inter-integrated circuit. So how many of you heard about this I2C? Because this is the uh, one of the famous hardware protocol that most of the sensors also available in the I2C format. Anyone is worked about the LCD display? For LCD display, like this LCD display. So in a educational institute will mostly use the 16:2 LCD display. Okay, so this 16:2 LCD display will most of the people might have to work with the 16:2 LCD display. What this LCD display will have, almost it is going to have 14 pins. Okay, out of that 8 pins are data pins, and 6 pins are some control pins. So that what happened here, we have to connect 14 different wires to the from this LCD to the microcontroller. So that what happened here, while we are connecting all these wires, even a small mistake done in the wires, that will irritate you. It will not, we are not able to do all those things, and all the while we are doing even a small difference in the breadboard, small difference in the jumper wire, a small difference in the connection missing. So these are all things will give some irritations. So that what happened here, later the people will comes with 16:2 instead of 14 pins. They design the same LCD with 4 pins, 16:2 with only 4 pins. There is no need to connect any other pins to this particular LCD. Only 4 pins are sufficient. So what are those 4 pins? One is VCC, that is a power supply, and one is a ground. And what about the remaining 2? One is a SDA, we can call it as a serial data pin, SDA, and the second one is called as SCL, serial clock pin. What do you mean by this serial data and serial clock? So this is called as I2C LCD. It is not called as a general LCD, it is called as a I2C LCD. So here itself we are seeing one advantage. Instead of connecting 14 wires, we are connecting just 4 wires, and we are making the connection successful, and we are writing and reading all the things. Sorry, we are sending all the information to the LCD over here. So like that, this I2C is the first advantage, that number of pins are completely reduced. That is the one advantage. Okay, let's see what is this I2C here. So this is introduced in 1982, and this is a lower speed devices. You can observe the speeds here. It is the standard speed is 100 kilobytes. If you want to make use of full speed, it is 400 kilobytes. Fast is 1 megabit, and high speed is 3.2 megabits. The highest speed itself is 3.2 megabits in the I2C. It's not lower speed, means it's compared to the it is lower speed compared to the other protocols, but normally it is a highest speed. That means this speed is sufficient to connect our sensors to the microcontrollers in non-critical applications. Means, for example, I want to connect automated car, like autonomous car, like self-driving car. So imagine that if in a self-driving car, if I use the I2C for communication to these particular different things, then what happen here? See, one sensor I attached to a car tire, for example, to measure the pressure of the tire, how much air pressure is available in the tire. I want to connect one sensor in the tire, and I want to connect this sensor to the controller which is available in the engine, which is generally available in the engine. So what is the distance, or almost it may be a 2 meters or 3 meters, maybe, because it is a back tire to engine, be 1-2 meters. Okay, but in that particular case, if I use the I2C, the speed levels are not sufficient, because in a self-driving car, the things should be very fast, because that should be done in microseconds. If some difference occurs, what happens to your self-driving car? Completely damaged. Okay, so in that particular such cases, we should not use the normal standard speeds or all these things. Okay, then we have to go for the preferably high speed I2C. And the people may ask that, so then if you want to go for the more speed, and then there are other protocols available here, so we can go for that particular protocols. Okay, and before that, and what is this I2C? It is I2C is a master slave communication. Again, first of all, what is this protocol here? We are going to connect the sensor to the microcontrollers. So once again, I'm telling that whenever we are connecting sensor to the microcontrollers, we will follow different protocols. So one of the protocol is I2C. One of the protocol is I2C. So what this I2C will follow, that master slave communication. So what do you mean by here? Master is nothing but your microcontroller or microprocessor is your master, and the sensor is your slave. Whatever the sensor that we are connecting here, that sensor will become the slave over here. So always the master, the controller, has to give some indication to give some commands to the sensor. Hey, please give me the information. So something like that. It has to indicate some. Master has to indicate some commands. Then only the slave device will send the information. So like it follow a master-slave communication. Similarly, slave has some unique address bits. Okay, similarly here, the slave should have some unique address bits. That means, for example, I want to connect 3 or 4 different sensors. So let us take the sensor 1. Okay, sensor 2, I want to connect the second sensor, and I want to connect the third sensor, sensor 3. Okay, and I want to connect the sensor 4. So all these sensors are going to be connected to a single master. Then what happened here? Each and every slave should have some unique address. For example, this is a number 20. The address of the sensor is 20. The address of this sensor is 30. Let us take some unique address. So like that, each and every sensor should be recognized by some unique address. So that is going to be possible in the I2C. That means, for example, I have a temperature I2C sensor. I have a I2C LCD display. I have a I2C some other humidity sensor. So something like that. I have different sensors are going to be available. So like each and every sensor will have some unique address whenever you are connecting to the microcontroller. So this is the structure that I2C is having. 2 lines. Actually, what we spoke, I2C having 4 lines, but what are the other 2 lines? One is always power, VCC, and other is always ground. See, whenever you take any sensor, this VCC and ground is compulsory. Without VCC and ground, any sensor will not be work because it's like a power supply for the sensors. So without these power supplies, the sensor will not be work out. Again, this VCC may be vary from 1.8. 1.8 is the 1 voltage, and sometimes it may be a 3.3 voltage. Sometimes it may be a 5 volts. So different power supplies are different depending on the different sensors. Different power supplies will be available. Okay, but anyhow, any particular sensor which is using the I2C means it has two wires, two pins. One is serial data pin, and other one is serial clock pin. So these are the two pins which are available in the serial communication. Here, can you anyone guess that what is this clock? This serial clock is nothing but it will provide some timing diagram for the data. That means someone has to guide the data when it has to transmit the data, when it has to receive the data at a leading edge or at a level edge or at a falling edge. So these things might be somewhat confusion for the other branch people, but anyhow, just remember that this is a synchronous protocol. That means the data is going to be sent based on the timings. The data is going to be sent based on the timing. So that is we can call it as a synchronous protocol. We'll simply call it as a synchronous protocol. Why? Because the data is going to be sent through the data is going to be sent through the timing diagram. Okay, that you have to remember. Okay, that is the I2C. So now can you I can ask one question here is that if it is a I2C, but what is the definition of I2C here is inter-integrated circuit. Then what is the length of cable? That for example, I have a sensor at some other place and I have a controller at some other place. Can I connect the sensor from that particular place to this particular engine place? For example, some controller place. Let us assume that there are a difference of 20 meters is available. So can I connect my I2C over here? So whenever the distance is very long, I'm not able to connect the I2C. So I2C will support maximum of I2C will support maximum of 220 meters. It will support up to maximum of 220 meters. But again, that will depends on the what kind of wiring you are using. Like whether you are using a twisted pair, means how you are twisting your SDA and SCL wires. Again, this is some electronic concepts, so don't worry about that. We can just blindly remember that for I2C will support up to 220 meters maximum capability. And again, that depends on the how much data rate you are using. For low data rates, for example, for 10 kilobytes per second, for low data rates, it will support the long distances. For low data rates, it will support the long distances. Whenever data rate is very high means it will support only low distances. It will support a minimum of 10 meters. It will support for high speed minimum of 10 meters length of the cable will supported by the I2C. Okay, so maximum, that again depends on the what I told earlier is that how you are using the wiring system, whether you are using a shielded, otherwise whether you are using a twisted pair. So depending on the wiring system, the length of the cable will be vary. Okay, so next one here it is a UART. So the next one is a very well known for all the people, like your monitors and all these things are going to be connected with this UART communication. Like here it is translate the serial to parallel. So again I don't want to discuss these points. Only a few points I want to discuss, like baud rate. So whenever you connect any devices, serial communication you are doing, whenever you are connecting any controller with your PC. For example, I want to connect my Raspberry Pi to PC. I want to connect my Arduino to PC. So how will you connect? You will use a cable. What is that cable? Is called a serial cable or we can call it as a UART cable. Most of the people are using that, but most of the people don't know that that is a UART cable. So because that particular communication is going to be done in the UART communication. See, most of the things we are using, but we don't know this, that is this particular protocol. See, at least we have to know the names of the protocols. No one is worried about the complete internal details of how the signal is sending, how the things are happening. That is not worried. We are not going to worry about that. But at least we have to know whenever we are working with IoT means we should have to know basics of which protocol we are using for the sensor and all these things. Okay, whenever you are using a Arduino is connected with PC and you are using some wire. What is that wire means? It is a UART cable. Okay, and it has single wire in each direction. See what happened here in this case in the I2C we have only single data line. If you want to transmit the data or if you want to receive the data, both should be done on the SDA only. If you want to transmit a data or if you want to receive a data, both has to be done on the SDA only. But here it is not like that. In the universal UART, we have two wires. That is, one is called RX and other one is called TX. Okay, so other one is called TX. So again, in the UART we have different types are available. RS-232 and RS-222 and RS-285. So RS-285 is a very famous one because in RS-232 we have only one transmitter and one receiver. Like for every transmitter and receiver we should require a driver IC. I will discuss about this driver IC later. This is a driver IC is a MAX 3232. So this particular driver IC is very important in a cable length, in deciding the cable length. So whenever you are work with the RS-235, RS-285, you can work up to 2 to 3 kilometers of wiring. The wiring length can be up to 1 to 2 kilometers. It's not like in meters. If you use the RS-285 connection along with some driver lines, some driver IC, if you are using like MAX 3232 or MAX 232, so some driver IC. If you use some driver IC along with RS-285, then you can extend your connection up to several kilometers, like 1 kilometer, 2 kilometers. It can go up to 2 kilometers also. That is for RS-285. So these RS-285, RS-232, all these will comes under the universal asynchronous receiver and transmitter, UART communication. And again, there is no clock in this, so it is a asynchronous protocol. Whenever there is no clock means it's definitely it is a asynchronous protocol. And the next one, we have discussed up to two things. One is I2C. One we discussed is I2C. Okay, I2C is a synchronous protocol. It is a half duplex because only single data line is available. Okay, and the second one we discussed about the UART. UART is a asynchronous because there is no clock terminal available in the UART, but it will support the long cables. Like sensor can be anywhere in a surrounding of 1 kilometer, so that from that particular place to your controller, it can able to do some communication depending on how you are wiring and what drivers you are using. Because without drivers, without having any drivers, if you want to work with the UART, you can go up to 50 meters. You can go up to 50 meters in the UART. That means it's the longest wire support. Like 200 meters, something like that also. You can go, without drivers, we can go only 50 meters, but with drivers, you can go up to 1 kilometer to 2 kilometers, something like that. Okay. Next, coming to the third one, here is the serial peripheral interface, the third type of protocol. Again, you can compare this with others. Why I have to go for the SPI? Because already I2C is good because it is having only 4 wires. Okay, UART is also good. It is having a 4 wires. Then why I have to go for the SPI here? Because in both these particular cases, data rates are not sufficient. What is the data rate here? Maximum 3 Mbps, not more than that. The maximum data rate of supported by these particular things is a maximum 3 Mbps, not more than that. So in that case, what we have to go for, whenever we want to go any sensor, it should be very, very critical. It has to give very high speed. Then we have to choose the SPI protocol. So what is this SPI? Serial Peripheral Interface. Okay, this is again developed by Motorola. Again, this is a full duplex because in SPI protocol, again we have 4 wires. VCC, sorry, we can call it as 6 wires, 4 data lines. 4 data lines means here it is a, we can call it as SCL. So we have some clock line. Okay, we have something called chip select line, CS, and also we have something called MISO and something called MOSI. What is this MISO and MOSI? That is master in, slave out, MISO. And similarly here it is master out, slave in. That means master is sending the data, slave is receiving the data. That is called as master in, master out, slave in. So like that, there are 2 data lines are available, MISO, MOSI. So that's why it is called full duplex, because for transmitting MOSI, for receiving MISO. Okay. So instead of TX and RX, simply speaking, instead of TX and RX, we are having MISO and MOSI. And similarly, we have a clock here. So it is a synchronous communication. And also this SPI supports very, very less distance, that is only 5 meters. SPI will support only a 5 meters distance only. That means the sensors who, if you want to connect to the through the SPI, means it should be very near. It should not be very, very far. Okay, in that situation, means very critical sensors only will use the SPI, where high speed is required. Okay. So some places instead of CS, they will use something called SS, slave select. Okay, slave select. Again, it is a master slave communication. This particular thing is a master slave communication. Master is always your microcontroller and slaves are always your sensors. Let us assume that all these are your sensors and these sensors are connected to your microcontroller. So for each and every sensor, there is a dedicated IO line. For example, here 3 sensors are connected. So there are 3 dedicated IO lines available for connecting your sensors. Means there is no unique address system here. Each and every sensor should have separate wire connection to recognize it. But earlier in the I2C, what happened here? There is no wire to recognize because every I2C is having some unique address. But here we don't have any unique address. Each and every slave should be connected to some IO pins. Means here again the wiring complexity in SPI. Again, if you want to connect to 2 or 3 SPI connections, then it is a complex connection. Like wires are so many wires are going to be required to connect your different sensors. So that is the only disadvantage of SPI, but advantage is very, very high speed. You can use it for memory transactions. You can use it for robotics applications. You can use it for this self-driving cars, something like that. Wherever high speed is required, we can use these particular things. And the next one here is GPIO. That is the last one, but very important one that most of the people are always work with the GPIO. So whatever the sensor that you are taken, you have only one single pin, D0, D1, D3, A0, A1. So all these things single pins. So what are all these single pins are called as a GPIO pins. So what do you mean by this GPIO means general purpose input and output. Okay, so this might be looks very simple, but it's very powerful. Why? Because again this GPIO will supports a larger length. A good length of support will be done by the GPIO. Okay, so general your LEDs, whatever the single lines, like your LEDs are connected through GPIOs, your switches are connected through GPIOs, and your digital sensors like light sensor, like fire sensor, like small digital sensors are going to be available. All these digital sensors can be connected through GPIO. So what is this I? I means here input. Input means sensors, whereas O means output. Output means your actuators. So most of your single pin sensors or single pin actuators are going to be connected through this GPIO. So if you want to connect more pins means you have to use a more number of GPIO pins. Okay. So this is something about GPIO. These are the 4 hardware protocols. Now let me simply conclude here. What are my hardware protocols? One is I2C. Okay, this is my first hardware protocol, and second one is UART. This is my second hardware protocol I discussed, and third one is SPI. That is my third hardware protocol that I discussed, and last one is GPIO. That is my fourth protocol. See, other than this, there are some other protocols also available. There is one wire. There is something called one wire protocol. I think I don't know. Most of the people might not be heard about this one wire protocols. That's why I didn't discuss about this. But this one wire protocol is a very good one because it is having internal memory to store its data temporarily. It has some internal memory to store its data temporarily. So why? Because sometimes what happen here, sensors are very slow, whereas your processors are very speed. So to get the data from the sensor, the processor need not to wait for the sensor. So that what happen here, the sensor will have some storage inside that. So it will generate some value and store it inside the buffer so that the processor will take the value without any delays. Okay. So this is going to be some different hardware protocols that we have. Okay. So next, the second category of the protocols. Now, up to now, we have seen that how to connect the sensor to the microcontroller. Only one part we have seen, sensor to the microcontroller. And the second part here is that how we'll connect the sensor to the microcontroller wirelessly without any wires. So up to now, what we have seen, all are wires. All I2C, UART, GPIO, everything is a wired technologies, whereas it is a wireless technology. Okay, so how we can connect the sensor to microcontroller is a wireless technology. So what are the different wireless protocols? See, I'm not only speaking about sensor to microcontrollers to gateway also. Microcontrollers to gateway also we can connect using Wi-Fi, using 4G, using 3G. So these are all also called as wireless protocols. We can use Wi-Fi to send the information from microcontroller to gateway, or we can use what we can call it as Bluetooth, Zigbee. So all these things. Okay, let's see here. So these are the different wireless technologies and what are the different frequency bands they are going to use and what are the different data rates they are going to take. I don't want to discuss all those things. Okay, just I want to give that this many number of wireless technologies that are available for the IoT. So in this case, this NBA IoT is evolving very fastly. So might be, and presently LoRa is dominating all the IoT protocols other than the Bluetooth and Zigbee. So Bluetooth is one of the dominated wireless protocol, and Zigbee. There is one more called Zigbee. Zigbee is nothing but 802.15.4. So this 15.4. So this is going to be Zigbee. So these are the 4 protocols which are used very popularly. After that, naturally our Wi-Fi. So without Wi-Fi, no one is living right now. So this is one of the popular one, and 2G or 3G. This is the older one. Now it is a 4G and a 5G. So we are going to use a 4G, and now also, of course, 5G is not implemented 100%, but there are some 5G dongles available, but that are not for 100% capability of the 5G. Okay, so the 100% capability of the 5G may be available within next 2 to 3 years. Okay, So these are the different wireless technologies that we can use in a IoT. Okay, let's go to the details very fast. Not like I don't want to give much details about all these things, but I want to give a few details about a few important wireless protocols. Wi-Fi, most of the you people know about this Wi-Fi. So what is the main important thing is that Wi-Fi is going to be used for, one is network discovery, because you want to connect your sensor to the cloud, but how you will send this sensor data to the cloud? In between you should have to use a Wi-Fi. So without using the Wi-Fi, otherwise of course Wi-Fi, or we can also use the Ethernet connection and all these things. But Wi-Fi is very comfortable. So without any wires, if you want to send any information from sensor to the cloud, we can use this Wi-Fi. Okay, and this Wi-Fi is having a different things are there. How many of you have heard about this 2.4 gigahertz Wi-Fi and 5 gigahertz Wi-Fi? So 5 gigahertz Wi-Fi is generally called as 802.1A you can see here ANAC. So this and here BGN, these kind of things. So these BGN will support the 2.4 gigahertz frequency, whereas this ANAC, this is support the 5 gigahertz frequency. Okay, but nowadays most of the Ethernets are supporting the 5 gigahertz slowly, not but earlier one, like up to now also we are using all 2.4 gigahertz Wi-Fi's only. There are few things which are coming with the 5 gigahertz frequency. Okay, what is the difference here? What is the difference between 2.4 and 5 gigahertz? Means this will support more data rates. Okay, this is only 2.4 is what happened here, only 54 megabits per second. But whereas your 5 gigahertz will support up to gigahertz of speed also. Of course, hundreds of megahertz, not exactly complete gigahertz, but hundreds of megahertz it will support. There is only difference between 2.4 and 5 gigahertz. These are the two open frequencies given by the government, so that they can use these two frequencies. Okay, next leading technology is Bluetooth. After the Wi-Fi, the next leading technology is Bluetooth. There are two types of things are there. One is that classic Bluetooth and Bluetooth Smart. You know, Bluetooth Smart. Now, what is the latest version of Bluetooth? Anyone heard a mobile in last 1 month or 2 months, or otherwise last 4 to 5 months? So if you buy any, not the lower end, like at least the mobile cost is more than the 20,000, then only they will provide the 5G for you. Okay, so now the latest mobiles which are coming with the 5G Bluetooth technology. Sorry, we can call it as 5.0, Bluetooth 5.0, not G, 5G. It is Bluetooth 5.0. So this is the Bluetooth 5.0 will support up to 400 meters of length. So this is one of the latest one, and it will support up to 400 meters of the length. And also this will support the mesh technology. What do you mean by mesh technology over here? See, for example, if we have a number of devices in a Bluetooth, for example, I have 4 or 5 devices are there. Let's take 6 devices are there. I want to connect each device to each other device, like this. So this is differently called as a mesh network. Okay, something like this. So I want to connect everything to every other. So then this becomes called as a mesh networks. So in your earlier Bluetooth, mesh network is not support. The like up to Bluetooth 3.0, the mesh network is not supported, but up to from the Bluetooth 4.0 and 5.0 is supporting the this particular mesh network also. But earlier it is only point to point, and this is also called BLE, not Bluetooth. Nowadays the Bluetooth is called as BLE device. BLE means Bluetooth low energy device. we should not call directly Bluetooth device. It is Bluetooth low energy device, that is BLE device. Okay, so that is about Bluetooth. So as you know that there are 3 different classes available in the Bluetooth: class 1, class 2, class 3. So depending on the how much power they are using and what is the length of the that Bluetooth data delivery length. So how much at what length the data is going to be transferred. So depending on that, the class will be decided. So your Bluetooth 4.2 and 5.0 will comes under the class 1. Class 1 means these are supporting more than 100 meters. Okay, so this is a Bluetooth. Earlier, the Bluetooth structure was it is going to be like this. So many home devices are going to be available in the Bluetooth, and these are the chips which are available in the market. If anyone wants to work with the latest Bluetooth like HM18, we can call it as HM18 Bluetooth 5.0. Anyone wants to work with the latest Bluetooth device, then you can buy these and you can connect it to your Arduino or any other Arduino, or we can call it as a Node MCU. Okay, these kind of things you can connect. So this is our latest Bluetooth 5.0 chip. It is a cost around only 200 rupees. You can easily buy them. Okay, next other than the Zigbee, next device is a other than the Bluetooth, the next device is a Zigbee. This is a competitor of your Bluetooth. I can say that this is the earlier it is a very because the Bluetooth itself, the Zigbee itself is supporting the mesh network from the starting onwards. So because in the Bluetooth there is no mesh topology is supported by the Bluetooth in the earlier days. So but the Zigbee supported the mesh network from the starting. So after seeing the Zigbee only, again Bluetooth they modified their version, and now the Bluetooth is also supporting the mesh network. But whenever you are going for Zigbee, it is very reliable communication. Means the communication is very standard. So that if you want to do any home appliances, or if you want to go for any industry, sensors are going to be talk to each other, because you know that in industry there are so many number of machines are going to be there. So one machine has to be communicate with other machine. So in that particular not only one machine to other machine, the machines has to be communicate each other, like it should be a mesh network. So for example, I have a 10 machines in my factory. So I want to all these 10 machines has to be speak each other. Then what happen here, I have to use a Zigbee in that particular case. Why? Because Zigbee is very reliable mesh network. So instead of going for standard Bluetooth, I will go for the standard Zigbee. Why? Because it is a industry norms. Industry norms are going to be supported very well in the Zigbee. And also the Zigbee, whenever you go for the market, there are 2 types of things are available: Zigbee and Zigbee Pro. Definitely he will ask whenever you go to the electronic market and you are trying to buy the things. He will ask, what do you want? Zigbee means whether you want Zigbee or a Zigbee Pro. So Zigbee Pro is a little bit advanced one, and which will support the more data rates and higher data length, distance. So it will support the higher distances. Okay, so in the majorly in the Zigbee, there are 3 types of devices available. So whenever you buy any Zigbee device, you have to configure the device either into 3 different ways. One is coordinator. So this is called as Zigbee coordinator. It is the main person who is controlling all the operations. Okay, and the second one is called Zigbee router. Router is a person who transfer the data from here. It will take the data from the coordinator and it will transfer the data to the other devices. This is called end device. This green color is called end device. What is meant by end device? There is no other communication. Further communication is not going to be there. It has to only receive the data. The end device are not able to send the data to other people. So whatever data is received, it will be stopped over here itself. It will not send this data to any other people. Okay, so that is what called as end device. Okay, so like this, Zigbee will follow this kind of structure. And Next protocol here is the 6LoWPAN. I think you people very well know that wireless personal area network. So this is going to be used for your home appliances, but again this is a low. Low means low power devices. Why? What is this low power devices? Your sensors are low power devices. Your IoT is low power devices, because IoT is not having a big things. It is very low power things will be available. Okay, in such case, whenever you want to identify your devices, then you have to use your 6LoWPAN. This is a networking protocol actually. This is not a wireless protocol. This is a networking protocol which will give some identity to the sensors. Sorry, we can call it as low power devices. So whenever you want to work with any low power devices, and if you want to give a unique ID to that particular devices, you can use the 6LoWPAN device, sorry, protocol. Similarly, the next one is NFC, and most of the people might have know about that in present days. Your debit cards and credit cards are coming with some NFC structure. That is, you need not to enter your PIN or you need not to enter anything. As soon as you've given the card to him, and he will just place the card onto the that particular device, automatically the money will deduct from your card. So that is possible because of NFC. But be careful. Better I can suggest all the people that you can disable that particular feature from your debit card or credit card, because we have a chance to disable it also. So why I'm suggesting you to disable that, whenever you forget, so anyone can simply take and buy something, and they can simply show your card to the machine, and the money will deduct without your permission, because it doesn't ask even OTP also. Okay, so such dangerous it is. But for easiness, because the people are getting lazy in nowadays. So as the technology is increasing more and more, the people are getting lazy. So because of that only this NFC comes. Of course, this NFC is having some other purposes actually. It will be generally used in shopping complexes to identify your products, and it will be used for barcodes. It will be used for scan QR codes. So these are all NFC, QR codes, barcodes, and whatever the other things like RFID cards, whatever your RFID cards that you are using, that is also comes under the NFC. Of course, everything is having its own advantages and disadvantages. So the next protocol that I have is 2G, 3G, and these are very common protocols that we are always see in our mobile. So I don't want to discuss much about these particular protocols. So these are the different wireless protocols. Other than this, one of the most popular protocol here is the LoRa. It's called as a long range and low power technology. Can you guess what is the range of this particular LoRa? The transmission is up to 10 kilometers in open area, because whenever you want to use any WAN, what is this WAN? Wide area network devices. Whenever you want to connect any one or two different places in a city, for example, in my city, I want to develop a particular application where I want to collect the information of temperature of different places in my city. So how do you collect that information? You have to deploy different informations at particular place. Okay, that is good. And nowadays everyone is using cloud, so everyone is sending that information to the cloud, and they are getting the information. That is fine. For example, I want to deploy all these things in the forest area. So if you go to the forest area, what happened here? In the forest area, there is no signal, no internet, no Wi-Fi, nothing. Nothing is going to be there. But still, just in the morning, I think Shiva sir has discussed that there are something fire accident happen in the California, sorry, San Francisco. I don't know what exactly the place, but some fire accident happened over there. But no one noticed that until and later it is done the complete damage. So in that case, in that particular places, we can install this kind of LoRa devices. As soon as something is going to be happen, it will immediately give the information for the next 5 kilometers within a seconds. So that what happen here, we can do our own remedies, so that to avoid that particular damage or something like that, we can do our own remedies. So the place where internet is not available, we can prefer this particular LoRa technology. So this is what structure of the LoRa, where LoRa gateways are available. So this LoRa gateways will send the information to the cloud directly. Next, so here sensor to the LoRa, we don't require any particular internet or something like that. Nothing is required. So this is a sensor. This sensor is going to be send the information to the gateway wirelessly without any. I think this don't think that these are wires. These are not wires. These are wirelessly connecting all these things to the gateways. Okay. So the maximum range of this LoRa is 10 kilometers. The next one is Sigfox, of course, but I don't want to discuss about this Sigfox right now. Why? Because it is not that popular in India. But of course, this started in the European countries. Of course, nowadays, I think last year, last 6 months back, there I saw 2 or 3 Sigfox sensors. I mean, Sigfox devices I saw from the last 6 months. Of course. I think the people are slowly launching the Sigfox into the India also. Okay, but again, what is the Sigfox? Again, this is also a 10 kilometer range of wireless device. But what happened here, in these particular wireless devices, we required antennas. Whereas in the LoRa, we required a very, very small antennas, not this much of big. But again, don't imagine that these antennas are like your GSM antennas, like your cellular antennas. Cellular antennas are very, very long, but these are not that much long. It is just 1 meter or 2 meter long. Only 1 meter or 2 meter long it is going to be. Okay. So, but these antennas will give the powerful communication over the these particular things. So Sigfox is almost a competitor for the LoRa. So they want to dominate the LoRa, and they want to create their own significance in the wireless technology. But anyhow, presently I can say that in India, Sigfox is not that much used. And okay, for the next one here, we discussed about the 2 different protocols. One is hardware protocols, and second one is our wireless protocols, and the third one is networking protocols. I don't want to discuss much about the networking protocols because everyone knows about IP version 4, how to give the IP address of the devices. So you can know 198.162. Some 1.1.1.1.1.2, something like that. We are going to provide different IPs for the different things. But this IP address specification is meaningless in IoT. Why I'm saying this, it is meaningless in IoT means there are lots of devices based on the IoT. There are millions and billions of devices which are following the IoT application. So for all the millions of devices, we can't provide the IP address using these 4 lines. So for that, the people are went for the IP version 6. The people are to avoid that particular length, they will go for the IP version 6. But again, IP version 6, we have a small problem that it will occupies the more power. So it is consuming more power. So because of that, the people wants to go for the 6 low pan. Earlier we discussed that 6 low pan is just an alternative for this particular IP version 6 for IoT devices, especially for IoT devices. To address this IoT devices in a global unique address, we'll use the 6 low pan instead of this IP version 6. Okay. Other than that, it is not that much differ. So this is the IP version 6 address. See how long it is, and these are all reserved. These can be used for the further purpose also. So it can be. I think for the next 20 years, we're not going to face any issues with the IP address. but after that again we'll face issues. So for that there are remedies are there already going on, but I don't want to discuss all those things right now. So just remember that IP version 6 is just advanced version of your IP version 4. Okay, so coming to the last one, we discussed up to hardware protocols, and we discussed about wireless protocols and network protocols like IP version 4, IP version 6, 6 low pan. These are all network protocols. And the last but not least, we have to send all this information to the cloud. So to generate the information, to send the information from gateway to cloud, we'll use application protocols. So what are the different application protocol? One is the famous, very famous application protocol is HTTP. Everyone every day they are typing some URL addresses. So those URL addresses are given by the HTTP. So it will simply follows the request and response type of communication. So now you can understand that where we are using this HTTP means HTTP is used between to send the sensor information from gateway to the cloud. We'll use this HTTP. Okay, so in the HTTP we'll have a get method, post method, header method. So like that we'll have different methods available in a HTTP to get the information and as well as to push the information. And the next version of this HTTP is WebSocket. I think CSC people might have some idea about that. This particular TCP and UDP. So one is a connection oriented, one is connectionless protocol, connection oriented protocol, something like that. We have all these things, but if you speak frankly, that this WebSocket is a little bit advanced version of your HTTP. So we can say that is a closed pipe connection. So like a kind of the data is going to be going through a closed ports instead of open ports. It will be goes through a closed ports. So that is nothing but your WebSocket communication. So simply speaking, that whenever your HTTP is going to be, for example, it is sending the request and then we'll get acknowledgement and then response, something like that. We'll get such kind of communication over here. So instead of this, we'll get everything is a closed connection, and that communication will be done between the sender and receiver. Okay, so who is your sender and receiver? So our senders are sensors, receivers are your clouds. And similarly here also clouds can send the information back to the sensors. Cloud can be a sensor here, sender here, and your sensor also may be a receiver here. So like that, WebSocket is a little bit advanced version of your HTTP. And last but not the least protocol here, it is a MQTT. So MQTT is a message queue telemetry transport protocol, which is given by IBM. So this MQTT will make use of this structure. So if you observe this, MQTT is a machine-to-machine and Internet of Things protocol. Especially HTTP is not always called as Internet of Things protocol, but MQTT is also MQTT is always called as Internet of Things protocol. Why? Because MQTT is having a very lightweight header. So MQTT is having only 2 bytes of lightweight header, and it will support the publish and subscribe methodology. You may ask one question: what is this publish and what is this subscribe methodologies? So these are nothing but we can send whatever the information that we want. We can send to a common place. After that, whoever subscribed to this particular topic, that information will reach to the other people. Okay. And the next one, last one, here is the COAP. So what is this COAP? Here is that it is similar to MQTT protocol, whereas it is also supports the same like HTTP, like it will support the request and response base. It will support again request and response base, but only thing is that HTTP will take 6 bytes of header size, whereas your COAP will take only 4 bytes of header size. But again, this COAP is specially designed for the industry people. So whenever machinery, because they are having a large machineries, they don't want to be make this protocol available for all the people. It is going to be constrained people. Constrained means limited. Constrained applications. Limited applications only will use this protocol. That is called COAP. Okay, constrained application protocols. So with this, I want to just conclude the things whatever I discussed up to now. Okay, so for my conclusion here, I have discussed up to now hardware protocols like your I2C, UART, SPI, and GPIO. Similarly, I discussed wireless protocols like Bluetooth, Zigbee, LoRa, Sigfox, okay, and Wi-Fi and near field communication. Okay, all these things are discussed in the second protocols, that is called as wireless protocols. In the third, there is nothing but network protocols like your IP version 4, IP version 6, 6LoWPAN. So all these things will come under the network protocols. And the last but not the least, application protocols. We discussed mainly about the MQTT, HTTP, MQTT, and COAP. So these are the different protocols that we are following in the different stages. So with this, I want to conclude my session over here. Okay, and I'm ready to take some few questions regarding these protocols and connections and all these things. And definitely, I hope that the next session is going to be a practical session. Okay, so you need not to sleep over here. So because that is going to be a little bit practical oriented. Sir, over to you, sir. Naman, sir.
Excuse me, Bharat. One question is there.
Yes,
Please
yes, sir.
see on the chat.
Okay, sir. 1 minute. Okay, sir. Please explain what is gateway. Unable to visualize it. Okay, sir. Sir, gateway means you don't think much about that particular thing. Gateway is a simple device which is going to be send your information to the cloud. For example, here you might have seen that. Let me maximize this. Okay, let me take some pen over here. So whenever you see that any devices like this, some boxes are going to be there. They are going to have
Your
some.
screen is not visible. Bharat, your screen is not visible. Can you share the screen once again?
Okay. 1 minute. 1 minute. Okay.
Yeah, now it's fine. Yeah. Please.
Yeah, okay. So it's a kind of box. Inside this, we'll have some Wi-Fi wireless technology devices like your Wi-Fi or your Zigbee, LoRa. So all these things are called as gateways only. For example, it may take any wireless technology. It may take LoRa. It may take Wi-Fi. It may take Sigfox, whatever it is. But this is a device. Gateway is a device. It can send this information to the internet, not only cloud or something else. What we can say that internet. So generally, all the gateways are used to send the information to the cloud. Sometimes what happen here, the same gateways are going to be available with the input output ports, so that we can connect some sensors over here. For example, I have 3 IO ports. I connected one temperature sensor over here. I connected one gas sensor over here. I connected some other sensor over here, and inside this particular thing itself, I connected my controller. So that what happened here, all these sensors are connected to the controller. Okay, after that, all these information is going to be processed and sent to the cloud over here. Okay, so then this particular, because of this Wi-Fi technology which is available in the device, then that is called as a gateway. Okay, I think it is answers the question. Okay, any other questions? Okay, sir. Naman, sir, I think.
So thank you very much, Bharat sir, for explaining hardware and software protocols in detail. So thank you very much, sir.
Thank you, sir. If any questions are there, you can contact me or Krishan. So whatever it is. So
Yes,
I'm
sir.
dropping my mail ID over here.
Yes, sir, definitely.
Okay. So right, with this, we can finish that, sir. Thank you.
Thank you very much, sir. Thank you.
Yeah.
So, Krishan sir, can we start the next session now?
We can start now, or you want some break, or otherwise I am okay with it. So as you
I think we should start now so that it will be wind up by 5. So it will be good for.
Okay, that's fine. Okay,
Yeah.
that's fine then. Okay, yeah, please. Okay, thank you.
So
I hope my voice is clear, right?
yes, your voice is clear. You can just turn on your camera.
Yeah, so actually I'm just going to explain through, practical oriented stuff and here. So I think I'm using one laptop and one mobile phone. I hope it's okay. So I'm going to share my PPT through the laptop and I will speak through that mobile phone. That is okay, right?
Yes,
We
no
can
problem.
do that.
Yeah, it's good. It's good,
Okay.
Krishan.
Okay, thank you, Bharat. And voice is, I hope voice is clear to all
Yes, yes, it is clear.
of you. Okay. Yeah, I request to Naman sir, please make me shareable. Krishan Patel, one no
Krishna
ID
Patel.
is there.
One second.
Yeah,
One
Krishan
second.
Patel. Yeah, please make me Oh, okay. Thank you very much. So, okay, still it's disabled participant.
I think, sir, you enable for extras. Can you please enable for Krishna Patel?
I've done that. I've already done that.
Oh, you done?
Okay, you
Okay.
can
Yeah,
try
now
once
it's
again.
fine. Okay. Yeah, thank you. Okay, fine. So, okay, let me
So,
open the
so dear participants, we are now moving towards the last session of the day. That is session 3. It is a practical session that is on IoT development kit and virtual lab demo. So it will be given by Mr. Krishan Mohan Patel. So I would just like to give you a brief introduction of Mr. Krishan Mohan Patel. So he's an MTech in computer science from Punjab University with a specialization in cyber security and a BTech in IT from Maulana Abul Kalam Azad University of Technology, Kolkata. He is currently working with Extrans Solution Private Limited, Bangalore. And at Extrans Solutions, Krishan has played a key role in the design and development of an IoT lab for a major technology university, design security upgrades for Extrans Cloud, implemented blockchain technology for IoT use cases, actively participated in the design of blockchain training program, and developed hands-on modules for the same. His aim to make secure, digital, and comfortable life for our society. And he has conducted 5 days training program for Wipro L1 engineers on fundamental of IoT and many NKN summer workshop on blockchain technology, Internet of Things, and practical implementation of smart city systems. He's also participated in E&ICT Academy, NIT Rourkela, Center of Excellence, IIIT DMK, Shan Bose University, NIT Warangal, and IIT Guwahati, and IIT Roorkee also. His area of interest include IoT, cybersecurity, blockchain, artificial intelligence, and machine learning. So we welcome you, sir, on our FDP for your knowledgeable lecture.
Thank you, Professor Namangar, for your kind words. And yeah, definitely, basically today whole talk is going on, IoT theory sessions, like how introductions and Mr. Bharat Kumar Alam given the talk regarding the protocols, SPI. But yeah, it's pretty difficult to understand, visualize all those things in the, in one frame. Okay, how we are sending the data on the cloud, and
Sir, sorry to interrupt you. You just mute your one of the device and just
okay.
unmute your one device from which you are talking.
Yeah, now it's fine, right? Okay.
Yes, sir.
Okay. Yeah, so it's a little difficult, right? So whole things like one just participant asks a question, so what is the gateway, how sensors are sending the data on the microcontroller, and microcontroller how sending the data to the gateway, and gateway sending to the data on the cloud. It's totally thing is that what is the overall idea? So we have to give the solution for our real time applications, like it might be a smart city, it might be your smart dustbin, and it might be your smart home. You can create any applications by using the hardware, software, and your things, whatever the things you want to be make it smarter, right? So here I will not take too much time on the theory session. This is the time to feel it, what is exactly IoT and how it's working, and principles, and how we are sending the data on the cloud. You already know about that protocols. You already know about that hardware and software protocols. So basically here the things I will just introduce 1 hour effort, that is Extrans IoT development kit, what our team is built for developing any such type of applications and any such type of protocols here. So our today topic is IoT development kit and virtual demo. Virtual demo I will show in the last. Before that, whatever the component is required, that I will discuss, and after that I will show you step by step. So now you can see, sorry. Okay. Yeah. So now you can see this one. This is the full diagram here for what exactly I want to going to discuss. Let me take the pen first. Yeah. So here you can see this is actually our IoT development kit, and this is designed by our Extrans team. So what is this kit? So what is the motto to design this kit is actually here you can see there is a lots of sensors are there, like this is the temperature and humidity sensor, this is the light sensor, this is ultrasonic sensor, this is the gas sensor, and this is the soil moisture sensor. So if you remember that like Siva sir and Bharat continuously told, right? So you can make the anything to be smarter, and you can connect anything to the cloud actually. So how can you connect those things with the cloud? Obviously, you need some parameters to analyze those things. Just take the example. Just take the one example of the pen. I want to make the pen should be smarter, and once ink will automatically get down and it will need to be refilled, then automatically I need to be some alert message. Okay, this refill is going to be like it's decreased, it's going to be like finished, so something like that. Then you want some alert message at that moment. What you will do? Definitely, I will put some those type of sensor. He will detect once that a vacuum will create, right? There is no air will come on that particular lid, then air will come, right? So those type of property you will analyze through that sensor, and that sensor will send those data to the microcontroller, and microcontroller will send the data to the Wi-Fi. It might be your Zigbee or it might be your LoRa, anything, right? It will send the data to your gateway, and gateway will send the data on the cloud. Very simple, right? So it's working, and after that cloud will see, okay, this is the data is continuously decreasing, like your ink is continuously decreasing, and once it will reach the threshold value, then it will put the alert message in your mobile phone. It might be in your email, it might be your any device. Okay, so this is a simple example I given because I am a instructor, so basically pen is very connected with me. So how can we make it smarter, like a smart pen, right? So I'm just giving the small example, but similarly you can give many more ideas like a smart dustbin, a smart gardening system, a smart home management system, and many more. So these all the things, how can you implement? Obviously, you require some prototype, right? Prototype module, firstly, you have to design it. So this is the board perfectly, who is the researcher, who is the, L1 engineers, who is really going to enter to the, real-time implementation. So where you will do the testing. So this is the testing board here, IoT development kit. There you can do the practice over it. So here I am using this two types of microcontroller. This first one is the Raspberry Pi. I think lots of people you are aware about that. Microcontroller is Raspberry Pi is a very common known microcontroller. Usually in the academia and industry, people are using it for making the smart applications. And the second one is also very cheap and best. That is Arduino. So you can do the programming over it. Okay, so now the question is, what is the motto? Like why we are sending the data on the cloud and where we can send the data. So this all the information, whatever the sensor information you are gather here, you are sending the data on the microcontroller, this Raspberry Pi, and this Raspberry Pi is going to send over your cloud. Again, the question is which cloud is good? Which cloud we have to choose for your application? So again, this is the questions you have to solve it. Like it fully depend on your application. If you have an industrial application, then you can choose AWS or something like that. So it totally depend on the application, what type of service you require. As per your requirement, you can choose your cloud. So here, basically, very basic clouds are ThingSpeak. So if today I will get the time permits, I will explain you what is the ThingSpeak and how can we send the data over the cloud. So usually, and this is our external cloud also. So for the development purpose, we designed this one for academia purpose. So if anyone interested to learn, then it's a very easy actually. This is very user friendly. You can send the data over the cloud and you can analyze over it. So that is very important part. Excuse me, Professor Naman, actually continuously I'm getting the participant request actually. Please admit. Actually, can you admit it? So I'm not getting disturbance from there. Okay. Okay, thank you. So what my thing is here. So here one more question is there. Like you all persons are different location. Like my colleague is on the Bangalore, Professor Naman is on a different location, and you people are taking this session in the different locations. Then how can you take the exam? So here what is the concept of the virtual lab here, right? So I just giving it up. This is the hardware lab, right? How can it become a virtual? So for making this a virtual, so we are using this software, or you can say the tool that is called VNC Viewer. So this is a VNC Viewer is actually the tool where participant or any user can log in remotely from any location. It's like a global access. So you can take the access of your Raspberry Pi microcontroller, and you can do the programming as well as, and you can create your such creative applications, and you can debug it, and you can test online through this VNC tool. Okay, so again the question is, what is the scope of this IoT development kit? Yeah, there are multiple scopes. Actually, this is not only limited on the Internet of Things. Obviously, if you want to do such, but I will not go on the blockchain and AI/ML because our concentrated topic is only IoT. So what I will do is I will focus on the IoT, but little bit I'll just introduce how can you do all the blockchain and AI/ML stuff. So blockchain also you can install over this Raspberry Pi and you can do the testing. Okay. So you know that, right? So basically we most of the time we are talking, okay, IoT is good, it's very flexible, we can control the device, we can do lots of things, but security always a concern regarding the IoT. In the inauguration session, also one professor, I saw that one, he also he is talking about the security perspective, right? So these are the things are, interconnected actually. So obviously, one technology can't give the whole features, obviously, but if we can merge the 2 or 3 technology and we can implement the stuff, if we are able to integrate all those applications, then definitely we can create a very beautiful application for our society. So you already know blockchain is, just like, provide is a very famous because of the security, because it's a very transparent things, and you can't you can't tamper those data inside whatever the data inside the block. And this is a public blockchain and private blockchain, both are there, but still that is very secure. So if we can integrate blockchain technology and Internet of Things, both technology at a one place, then definitely that application will be wonder actually, and we can create wonder in our society. So now the second thing is, already we discussed a lot, that is AI and ML stuff. Obviously you can do the experiment AI and ML. So basically a visual analysis in the Raspberry Pi, that is also support camera and all those things. If you have a USB camera, you can also connect. Otherwise, if you have different types of SPI camera, that is a port is here. You can see this is camera port is here. So you can connect over it, and you can do lots of experiments like visual analytics, like object detection, facial recognition, and many more such types of application you can create through the DNN, ANN, and lots of algorithm you can use over it. Okay, so now the whole perspective. So firstly, I will explain today on VNC how can you take the remote access of your IoT development kit, because today whole talk is on that IoT development kit only, and how can you, and in the last, if I will give the time permit, then I will give one participant to virtual login from their from that location. So please, whatever I'm telling you the steps, please, if it is possible, please download it, that application, that tool actually, and after that I will give our credentials, and you can take the access from your location, and you can get the better experience here. So that is the whole idea. So it's not like a theory session. It should be a very interactive session. If you get any issues, please just text me in the chat box. I will try to give you answers quickly. Okay, so here this is my first talk to be VNC viewer. So how can you download it, and how can you create the account? And second talk will be on this Raspberry Pi and IoT development kit. And in the last, if I will send the data on the cloud. So this is the whole idea here. So firstly, I'm just without any delay, because time is we have very less time, so I have to cover lots of things here, and usually practical session is taking time. So okay, so virtual login. So what is the tools you require to do the virtual login? So the first one is create the real VNC account. So as so always we have to create the VNC account. So firstly, creating the VNC account, link is not given there. So I'm just trying to, okay, I will text you in the chat box, don't worry. So you have to create the real VNC account. Second step, you have to do VNC server. You have to join, and you have to define your IoT Raspberry Pi. So I will tell you how to do this steps. And in the last step, what you have to do, download the VNC viewer. So this step, please, you have to also download. Step 3 you can do right now itself if you have a laptop right now in front of you. Download the VNC viewer. Just type in the Google, download VNC viewer, and automatically you will get exe file. And as per your system, if you have a Linux, then please download. Please download as per your. If you have Linux, then Linux operating system for compatibility, you can download VNC. If you have a Mac, then you have to Mac compatible VNC tool you have to download. And if you have a Windows, then you can download exe. executive file you have to download. Got it? So this is the step 1, step 2, and step 3. You have to, this is your, just now you can see this is your classwork. Just now, please download. In the last, I will ask you to do the remote login in the last. Okay, fine.
Yeah, Krishan, one small interruption. So, Krishan?
Yeah, please. Bharat.
Yeah, sorry to interrupt you. But I think meanwhile, can you switch off the video so that I think it will support some bandwidth. And again, in the last, we can switch on the video.
Yeah. Sorry. Now it's fine.
Okay. Fine.
And now my voice is, I hope my voice is clear for all, right?
Yeah, it's clear.
Okay, thank you. Okay, so you can see this is basically, firstly you have to do the sign in. This is here you have to put your email ID and real VNC. Just a minute, I will send you in the chat box. Okay, so real VNC. I'm just sending you the link as well as, so you will not get any confusion. Real VNC login. Okay. I'm just copy this link address, and where is my chat? Chat here. Okay. So yeah, Bharat, if you are there, please send the all link also, so I can save my time and I can continue my session actually. So please share the all necessary links through the Google. Okay, thanks. Yeah, okay. Are you able to hear me, Bharat?
Yeah, I can hear you.
Thank you. Yeah, please put on the chat so I can save my time. Yeah, thank you. So so let me start the PPT. So here you can see you have to put your email ID first. Once you put that your email ID, oh, what happened? Something happened. Where I'm not getting the pen here.
You just click on that. Click on the screen. No, maximize it. Click on the screen. You will get in the down left hand side.
Yeah, actually, yeah, something is problem here. Wait. Where is my pen?
No, unless you are not going to slideshow, you will not get the pen. Yeah, left hand. You can come completely left hand side, right corner, down. Left corner down.
Yeah, actually in the corner I'm getting a window screen. Okay, anyway, I will see that one. Okay, no issue. So here you can see, just see my mouse cursor here in the mouse. Please observe it. So here you have to put your email ID. So once you will put your email ID here, so it will ask what is your password and all those things. So use what that is once you are create the Gmail account, the normal account creation process. That is the same way. You have to give your email ID, you have to give your password, you have to give your name and other stuff, and you have to give your mobile number. So once all the things you did, then it will say in your email ID, please verify your email, right? So whatever your email ID you given, so that email ID you have to verify, and after that you will get all those access of your VNC. So see here that verification part done, and you can see here I'm getting the account, welcome to your real VNC account, and here you will get the profile, security, what do you want to do, lots of things they will ask, and after that you have to active your cloud. So basically all the things is happened in the remotely, so you have to send through the cloud only, right? The data is sending to the cloud, so you have to activate your cloud here. And after that, so second step I am talking about that IoT development kit. Okay, just a minute. Yeah, so once it will successfully log in, then you will get this type of screen. So this is basically your VNC viewer login. So let me open that VNC. So I will show you how it will be look like. VNC viewer. Okay. So already I VNC viewer I installed. That's why it's appearing like this logo. So you will, because my system is Windows and I installed that Windows application over there. Windows application compatible VNC viewer here. So I'm just going to open that VNC viewer. So now you can see this is the multiple things are showing there. This is my Extans 02. Okay, so I'm just trying to log in. So already my kit is on here. So now you are able to see how it looks like my screen. So you can see this is the by default username and password is asking, and this is the password RSTBERRY. That's very, it's a by default password. And now you can see this is a beautiful screen will appear on your desktop. Okay, so this is the screen actually of your IoT development kit, and internally lots of people will ask what is the OS. So this is the Raspbian OS is installed inside your Raspberry microcontroller. Okay, and you can do lots of programming stuff there. Basically these are lots of IDs. Arduino, you can do the experiment also. Genie is one of the editor. You can do the Python coding over there. Red Node flavor is also there. Python is there, and many more small. So it's like it's a mini computer for you. It's the size is very a credit card size controller is there. So that's why people, it's a very famous in the academia as well as the industry, and you can create like a really a wonder application by using this Raspberry Pi actually. And yeah, so in the slides you can see their VNC is there, right? VNC viewer, what is installed. So here you have to do the licensing actually. So this is already I did the licensing. So belonging to Christian Steam Home and connecting users, see this information and all those things. So you can do the signing. So once you will install that VNC, then you have to do the licensing part here. So where is that licensing? Here is the licensing part. Inside the licensing, whatever you given your email ID and password, you have to put your email ID and password here. And after that, you have to do the signing. So once you will do the licensing, then your Raspberry Pi, like your IoT development kit, is registered for you, and you can take the remotely access from any location. Okay. I hope up to here is clear. Now question is coming, sir. If earlier licensing is not happened, then how can we do the thing? Because virtually definitely we not connected. Then obviously you required one desktop for that. So through the HDMI cable, all these necessary stuff you have to do first by using your mouse, by using your keyboard. Okay, by using, I'm repeating once again, by using your mouse, by using your keyboard, you have to repeat, you have to configure all those things like a VNC viewer and all those stuff. And once it will done, then you can proceed with it. So then after that, you can give your username, password, and after that, you can take the remotely access over it. Okay, fine. So this part is done. Licensing, you understand. Now I'm going back to the PPT. So now you can see this is you understand. The second licensing you already did, licensing part already you finished. So now you have to give some computer name here. So some computer name is the thing, but you have just you are doing some setup. Okay, what computer name you want to give? If better, if you want to give the name, your application name, what you are going to develop, that application name also you can give. But this is up to you. It's your choice. Now the fourth step is in the free trial. Actually, you can only in the free trial only you can connected like only 5 members you can connect at a time, like 5 members. Like you can't computers now. You can 5 members only you can take the access. It's not like that, multiple members or multiple device you can connect. Only the 5 device and 5 members you can take the access. That is the only restriction. But yeah, obviously if you want to upgrade your service, your service meaning is that if you want to do the more business over that real VNC, you want to connect more applications, more devices, then definitely you have to pay to the VNC viewer. Got it? So these are the third-party tools. So you have no need to worry. It's a very flexible. Once you will do login and all those things. So once you learn, that is very easy to learn any smart applications. You can create any such type of smart applications. Okay. Now come on the next one. So laptop part. Yeah. So already you set it out all the VNC related things on your Raspberry Pi microcontroller kit. Now the second step is on your laptop. So already I told, as per your compatibility, you have to download that particularly tool, VNC tool. So here you will get the link. Already link is, I think, Bharat pasted over here. So please go through this link and download your compatible VNC tool. So here mine is Windows, so that's why I downloaded this one. And once you will download, then you will get that, now I'm getting the pen. Hang on. Okay, so once you will download this one, so you will get, you can download, and after that, you will get the VNC icon in your Windows Start menu. After that, you have to do the sign in. So here is the sign in button. So same user ID and password I will share with you. So once I will share with you, then you are able to do that login. But before that, I have to authorize it. Once you will do the sign in, right? Then I will get one email. Yeah, this person wants to get your access to your IoT development kit. Are you permit or not? So once I will permit, then you will get the, okay. So now the thing is, now you can see this is the third step. You have to give the email ID. This is your password. You have to put it, and once it will done, then see here you have to give the continue to sign in. Once I will approve, then you are able to do the sign in button. Okay. Now this is the things, and this is the sign in authorize button. This is the sign in authorize button. So I am going to authorize. So it's done. And after that, you will get this type of screen. Just now you saw that one, right? So just now you saw that one. This is the first type of screen. Earlier I got it in the real VNC. Same like that, you will get this type of screen. And you saw that one, right? I given this Pi and Raspberry Pi. Sorry, Pi and Raspberry Pi user ID and password. So this is the by default. Pi is by default, username, and password is Raspberry. This is by default username and password. If you want to do any changes, also you can do that one. That is not a big deal. It's the same like your laptop password and username. It's not different than that. Okay, and once you will do the login, then you will get this type of screen. That is very so screen can be changed. If you are install some other type of ways, then definitely screen will appear in the different way. That is not very, but obviously the main thing is this upper part that will not change. This start menu definitely will get. This browser you will get. One folder stack you will get. This is your console, and this is your node RAID node. Also you can get, or sometimes it will not appear. Then you have to check in the start menu. And VNC already I explained. So in this Raspberry Pi controller, this is Bluetooth, Wi-Fi, and sound. All the things is available. So no, this is a full-fledged, all sensors. Like all necessary hardware components are there. Like a Wi-Fi module is there. All modules are there. Bluetooth module is there. Sounds and all the things are there. So you no need to worry about it. All the things will be taken care, and it's a very robust. You can use the application, and you can run like 24/7. You can run the Raspberry Pi. It will not be damaged. It's very robust also. Okay, so now I'm just going to talk about that second step, that is Stance IoT development kit and accessories includes. So what is that taking care like in the IoT development kit? So in this kit, actually, this is a Raspberry Pi contains, and also it contains LCD display, 7-segment display. This is your relay. This is the serial monitoring cable. Also, you can interface. Also, you have a buzzer here, Also, this is the 7-segment display, and this is the keypad matrix. If you want to do some, matrix performance or some calculator application, if you want to design, then also you can design over here. And this is your Arduino microcontroller if you want, and this is your Wi-Fi module. So for this is Wi-Fi module is basically for sorry, for your Arduino actually. Because in the Arduino Wi-Fi model is not available, that's why we have to connect the Wi-Fi model externally. So this is a ESP8226. This Wi-Fi model I have to connect through the Arduino. Now I'm talking about this sensor. This is the RTC actual real-time clock. So you can see this type of things is available in the every electronic device like a TV or a laptop and all those things. So these things is available everywhere. And the second thing I explained. This is your star master sensor. This is a gas sensor. This is the ultrasonic sensor. This is your light sensor. This is your temperature and humidity sensors, and this is a 5-volt and 2 amperes adapter you will get through this one, and Star Master Pro. So one person you can ask this one. So sir, only these type of sensors can we connect, or other types of also sensors we can connect? So yeah, definitely we can connect other types of sensors. So there is a lot of open ports are there. You can see here. There are lots of open ports are there. These are the open ports are there. So you can connect your sensors over this open port, and you can configure as per your requirement. Like in the different applications, you require different types of sensors, right? So here only the temperature sensor, light sensor, ultrasonic sensor, gas sensors are available, but not other than that applications are available, correct? So you can connect the other applications by using this. By using these external pins, you can connect the others. Like just take the example. You are just one person came and he told, please create one smart healthcare applications, and you require for that pulse sensors, temperature and body temperature sensors. Then those sensors are definitely it's not available here. So where you will connect that? So definitely you can connect over here. Okay, you can connect through that external pins, and you can create your applications. So, but yeah, for the prototype, basic prototype, you can use these 5 sensors, and by using these actuators, you can control over this, and you can successfully create the application. Then what is the use of that actuators? Why we are using the actuators? This is the question you can ask, right? I will explain what is the use of actuators. Just you can see here. In this temperature and humidity sensor, you are sending the data on the microcontroller through the SPI, what Bharat earlier told regarding the protocols, right? So you are sending over the Raspberry Pi. Now Raspberry Pi is sending the data on the, if you have a gateway, then it will send to the gateway, and gateway will send the data on the cloud. Okay, this is your cloud. I'm just giving the C, and this is your G, gateway. Okay. So just see once I'm just giving you one example, like a temperature sensor. Temperature sensor is sending the data on the cloud, like it will reach the 30 degrees Celsius. It will reach the 30 degrees Celsius. Then I want one action performed, like AC should be off. Once it will if it will reach like a 25 degrees Celsius, then AC should be off. Otherwise, it will, then I put the condition, right? So if it will go beyond that 25 degrees Celsius, then only AC should do on. Then it will send the data here, and this will, and here is a GPIO pins. Okay, this GPIO pins is internally connected with the all sensors actually through the jumper wires. Okay, so this is the connected here actually. So whatever the data you are sending, according to condition, he will perform, and he will tell to that relay. Okay, relay will, what he will do, once temperature will reach on this particular condition, relay will be on, otherwise it will be off. So such type of action you can perform by this kit actually. So this is the thing, and whatever the data you want to send, it will send the data on the cloud. And you can, in the cloud, if you will put some your message you want, then you can subscribe your message. If you want something, email, then subscribe your email. Then you will get the alert message over your phone through the email, or might be your message. And yeah, SO series also you will get a USB mini, USB cable, a stepper motor you will get, and sensor cable you will get, telemetry connection cable you will get, actuators cable you will get. So all pins and cables you will also get, including with this kit. Okay, this part is done. This is now I'm coming on that one thing, that is the cloud part. Before I'm going to the cloud part, I want to show something, how can you take the access. So I will just tell to the Bharat. Bharat, are you there?
Yes.
Yeah, hello.
Yeah. I'm here.
Yeah, Bharat, can you take the, remotely login? Can you show to the participants how they can do the remotely login, and small just temperature sensor, how they can retrieve just in the 5 minutes? Can you do that one?
Yeah.
So basically the idea behind that, why I'm telling to the Bharat, basically you will say like that, right? So Kit is with you, and that's why you are able to log in and all those things is happen. So Kit is with me right now in the Patna, and Bharat is in the Bangalore, and he is now accessing my IoT development kit through the Bangalore, and he will do some applications and some use case application. He will just a prototype model he will create over that IoT development kit. Okay, Bharat. So I'm just stopping sharing here, and please, connect with it. I think user ID and password, please log in and share the screen.
Okay.
Okay. Yeah. Thank you.
Yeah. Let me share the screen here.
Yeah, please, do conclude a little fast. So we have a less time, so we have to,
Yeah.
Okay.
I will do.
Okay.
So I'm just sharing my screen over here.
Okay.
So I think you're able to see my screen.
Yeah, Bharat, I'm able to see your screen. Now you can proceed.
Okay. So for the participant's sake, just I'm explaining that I installed a VNC viewer. So we have given that link for you in the message box. So you can please download that VNC viewer and install it in your laptop. So here also I installed the VNC viewer. So let me open that. So let me open the VNC viewer here. So this is my VNC viewer. So let me open this VNC viewer. So as soon as I open my VNC viewer, it will be looks something like this. Let me sign out from here. Okay. So this is the empty. It will be looks like this for you. So whenever, as soon as you open your VNC viewer, it will be looks like this. Okay. Now I want to access the Krishan's IoT board.
Hello, Bharat. Are you there? Your voice is not coming.
And that this should be same as the username and password, which is enabled in the Raspberry Pi. For example, last time you have seen that open the Raspberry Pi licensing part, and there you enter the username and password. The same username and password we have to enter over here. So I'm just entering that, and after that I'm entering the password. Okay, just sign in. Okay, now I was signed in over here, and now I'm able to see all these kits, like the kits which are registered to this particular VNC account. So these are the different kits which are registered for this particular VNC account. So let me open. This is the Krishan's IoT development kit. Let me open that. So by double clicking it, it will ask for the username and password. Okay, so username and password. I'm just typing the password over here and entered. So well, now I'm entered into the Krishan's kit here. So now I can write my own programs over here. Okay, so now everything I can control from here. Now I'm in Bangalore and Krishan is in Patna, but now I can take the control of his kit from Bangalore. Okay, so let me do one thing. Let me show you a sample program here, so that how can I get the sensor information from that particular kit. Okay, so let me open for the programming part, and this is Genie. So Genie is a IDE to write my Python program. So I'm just opening this IDE here. Okay, this is a small IDE that I can write my Python program here. So there are already some programs are available. Let me close this. Okay, so let me write file new. So now see here, it is showing some new Python file over here. Okay, so let me write the program here. Before writing the program, let me save this program. Save as. Let me save the program as I want to write a program for DHT.py. What is this DHT here? Digital humidity and temperature. I'm writing a program for reading the temperature and humidity values from my kit. Okay, so this is what I'm writing. That's why I'm naming it as a DHT.py. Let's save it. Okay, already is there. Okay, I want to replace it. Okay, now I can write my program here. So in this particular program, if we want to write here, what is the intention of this program is? Program is to read the. Okay, program is to read temperature and humidity, T and H, both temperature and humidity I want to read. So for that, first I have to import the library related to that temperature sensor. So what is this here? It is that library is called Adafruit_DHT. So this is my library that I can download and importing into the program. So this library is capable of reading the values from DHT sensor, that sensor which is available on the board. Earlier, Christian has shown that this is a temperature and humidity sensor. So to read the values from that particular sensor, I have to import this library. Okay. Similarly, I want to just define two variables. What is my sensor type here? Okay, and what is my sensor pin number? So what are the two these variables are? One is a sensor type, because in the DHT there are three different sensors available here. One is the DHT11, okay, DHT22 and DHT21. You may ask the question here that what are these three? These three are temperature and humidity sensors only, but with different flavors, with different range of frequency, range of temperature, with different accuracy rate. Like these two are more accurate. This DHT22 and DHT21 is more accurate, like only plus or minus 0.5 degrees difference in the temperature. Whereas for our DHT11, there is a plus or minus 1 degree temperature difference is going to be there. Means if originally is 24, we may get 25 or 23, something like that. Means 1 degree less or 1 degree greater we'll get. Okay, and our sensor is connected to the GPIO number 4. In the Raspberry Pi, we have different pins available. So in that, our sensor is connected to the GPIO number 4. Okay, let us read continuously. So I'm just writing while true. While true is nothing but an infinite loop. Okay, so that's I want to read the sensor values continuously. So for that I'm writing like this. So I'm reading what are the two values I'm reading. That is, one is I want to read the humidity into this variable and temperature into this variable. So how to read that one? So to read that, we have to write DHT dot we have to write DHT dot read underscore retry. Okay, so here I have to give two parameters over here. So one parameter that I have to give is a sensor. Yeah, 1 minute. Sensor type, comma sensor pin. So I have to provide these two information to this particular library called read underscore retry. This is a method inside the DHT class. Okay, so this method I'm calling to read the values from the sensor. Okay, let's close this and I'm just printing the value of humidity. That's it. It's a very simple and easy program. Only few lines are going to be there, and just give some delay so that I don't want to read the values continuously. I want to read the values for every 3 seconds. I want to read the values for every 3 seconds. So for that I have to write time dot sleep. So for that I have to import the time library over here. So let's import time library. Okay, now this is just 1, 2, 3, 4, 5, 6, 7, 8 lines of programs. 8 lines of programs here. Program is this. So let me run this and get the value of temperature and humidity. So Krishan, have you connected the temperature sensor?
Yes, Bharat. Yes, I am connected. I connected that one.
Okay, right. Thank you. So just save this program here and try to run this. See here, I'm completely, this kit is available in the Patna and I'm running everything from the Bangalore. So this is the output. I think we got some phd.read underscore. Int argument must be a string and not module. Line number 11. Yeah, just a minute. Line number 11. Okay, here sensor pin we have given the wrong, it should be 4. I think it is modified over here. Okay, that's it. So just
Yeah,
change
yeah.
that.
Only 4.
Yeah. Okay, just run this program here. So now we are getting temperature 32 degrees and the humidity is 95%. So in that particular Krishan's place, the value of temperature in that particular room is 32 degrees centigrade and the humidity is 95%. So this is a way how the people can log into that particular key and they can write their own application over here and they can learn all those things. And of course, the connection details and sensor details, those things we can take a video of video kind of thing and we can show them for the remote people. For example, now Krishan can switch on his video and he can show everything, every connection, how it is
Yeah,
going
but
and
I'm
all
just.
these things he can
Can you
show.
explain? I will just show the videos, so you can explain. So whatever I will listen, I will show the video. Yeah, please. Are you able to see that?
Yeah. Just I want to. No. Actually, for that I have to. Um, I can able to see, but the participants are not able to see. No.
I hope can anyone can tell
No.
they
I
are
think
able to see or not.
for that.
Just stop the sharing screen and after that we can I think explain. Yeah, okay, I will explain just now. So this is the temperature sensor what Bharat is talking about, and this is
No, no,
DST 11 temperature. Yeah.
Krishan, you
Fine.
can give a no full screen. I want because presently it is running with me, no? So okay, one
Okay.
minute. Yeah. No, the participant has to like pin video.
Okay, now it's fine.
Yeah. Just I'm telling the participants to that pin to Krishan's video so that you will get the full screen over here.
Yeah, okay. So now you can see this thing. So basically, here is the temperature and humidity sensor. So this is basically connected on that, through this relevantly cable.
Krishan,
and
we are not able to see the temperature sensor.
Are you able to see now?
A little bit.
Okay, fine.
Yeah. Now it is fine.
Now it is fine. Okay. I will fix as it is. So this is the temperature and humidity sensor you can see here, and this is connected through this cable. And this cable is how it is sending the data on the Raspberry Pi actually. So this is actually Raspberry Pi is connected with this, by this cable, and this cable is passing that data on this, and this will send the data on the cloud basically. Because cloud program is not written yet, so only it's sending the data on the Raspberry Pi. And in the Raspberry Pi, whatever you've seen in the console, so it is gathering that information like a temperature value, humidity value, and if you want to perform any action, then here is the temperature and relay is also there. So you can see this is this is also connected over here. So temperature and
buzzer.
Buzzer and relay is also here, right? So you can connect the buzzer and relay. And if you will one line of code, you will give some conditions. Might be Bharat, if you get time, but we will also show how can we buzzer, we can switch on and switch off. We can do that one.
Yeah, we can do that.
Once it will so temperature, once it will reach on threshold value, then we can turn on the buzzer. So I will show you the sound and all those things. Once Bharat will write the program over there. Yeah.
Okay.
It's up to you. If you want to add something, yeah, please add there.
Yeah, that's fine. So that is a way that how we can connect with the things, and we can show. Of course, we can use everything that we can explain through the video, and we can connect. We can explain the connection and all. So after that, let me share my screen here. Okay, so I will show a simple program to how to connect the buzzer and all here. Okay, so let me just share my screen here very quickly. Okay, so this is my screen I shared over here, and just see this is the Krishan's Raspberry Pi. Are you able to?
Yeah, Bharat, I'm able to see your screen. Please go ahead.
But I'm not able to access your Raspberry Pi. No, I'm not able to access your Raspberry Pi.
Okay, wait. Something's problem.
So let me connect it once again.
Yeah, please connect once again.
Yeah, let me click on and connecting once again. No, server is not listening for cloud. I think there might be some internet problem.
Wait. Yeah, just a minute. Yeah, I think so. Now just try once again, Bharat.
Okay.
Let me disconnect and connect once again.
Okay.
Yeah, now try once again, please.
See, for connecting these things, our internet should be very, very good. Otherwise, we'll face the problems. No, still.
No. Okay. Oh, okay. Wait. I will do switch off and switch on. Turn off.
Okay.
And turn on.
Okay. Right.
Turn on Wi-Fi. Okay.
So right.
So sometimes.
Right. So before going to that, let me just explain about the cloud here. So that is okay. We up to now what we did is that I access to the Krishan's particular kit and I have written the program for reading the temperature and humidity sensor. So similarly, now I want to send these things to the cloud. So for that particular purpose, we need to have some clouds over here. So let me explain one cloud over here. That is, I think you are able to see my screen over here. That is thingspeak.com. Okay, by simply typing thingspeak.com, thingspeak.com. So by typing thingspeak.com here, we'll get some screen over here like this, and we can log into here. So just by clicking on this sign in symbol, I can log in here. So I'm just entering my ThinkSpeak account username. Okay. Similarly, I am entering my ThinkSpeak account password. So I'm requesting you, all the participants, you please create your ThinkSpeak account. This is free for 3 years. So anyone, if you want to create any of these things, it is free for almost 3 years. Okay. So in this particular ThinkSpeak, we can create channels. So these are called as channel. If you observe that there are already I created 4 channels over here. One is smart environment. Okay, one is smart agriculture. One is COVID-19. Earlier we did for COVID-19 counter, and I did one small program for IoT. So like that, for different applications, I created different channels over here. So let me enter into this smart environment monitoring. Just clicking on this. Okay, by just clicking on this, you can see that there are different things available. Already I sent so many things to this particular cloud over here. See this temperature, it is showing 32. Okay, here it is humidity, it is showing 95. And similarly, it is showing some light value, and it is showing some gas value. So like side by, you can observe that side by you have light value, gas value, temperature, and humidity. But what happened here? What are these called as fields? See here, FIELD, field 1, field 2, field 3, and field 4. So like that, we can create up to 8 fields over here. Here we are created only 4 fields in this particular application, but maximum we can create up to 8 fields. So something like that. ThinkSpeak is providing free up to 4 channels. Okay, each channel is going to be create 8 fields. So like that, 4 channels into 8 fields. Totally 32 fields we can create. What do you mean by these fields? Here is sensor information. That means we can send a 32 different sensor information to this particular cloud for free without paying anything for the next 3 years. Okay, so next 3 years data we can easily maintain over here. So like that, for each account we can send up to 9 million messages. So whatever the message that you want to store here, maximum you can go up to 9 million messages. I think it is almost 90 lakh messages. Okay, so that many number of messages we can do free transactions in the ThinkSpeak. That is the main advantages here. And also there are some apps available like ThinkTweet, so that whenever anything happened, like temperature rises certain condition, or otherwise something happened, some door is unlocked. So whenever one condition met, we can give a Twitter message to the people. We can give a time control. So according to particular time, I want to deliver something. So according to that time control also, we can do so many things over here. So like that, all these things we can do using this particular ThinkSpeak. So this is so many advantages are there here. So we can do all this analysis over the cloud part once we got the information from the kit. Okay. So Krishan,
Yeah.
are you ready?
Yeah, Bharat, somehow internet is not connected with that one actually in the Raspberry Pi. I'm trying to connect, and keyboard right now is some problem. So let me try once again.
Mm-hmm.
1, 2, 3, 4. So Wi-Fi is disconnected actually. Can we do something? So there is a virtual keyboard is there in that Raspberry Pi? No, right? Some other keyboard options we don't have.
So just give me a minute. Give me a minute.
Okay. Okay, just
Hello.
So you are opening that your kit there. Somehow it's disconnected and it's not trying to reboot. Okay. We'll do one thing. Okay, we'll do one thing. I will remove that password, so might be it will automatically reconnect. So this is the one option for me. Okay, Wi-Fi hotspot name. You see, this is the one option for me. I hope it should work.
Yeah,
Hello.
we are sorry. I think just give us a minute. I think he's doing some settings over there. I think might be some internet problem.
Yeah, now it's open. Bharat, can you try once again? Internet is connected, and can you try once again, please?
Okay,
Yeah.
okay.
Yeah, it's connecting. Bharat, you can carry on.
No, Krishan.
No. Yeah, it's not connecting. GNC is not currently listing the cloud connection. It's connected with internet. Let me open the browser and check. So it's working or not. Okay. In the VNC, I think there is some problem happened. Okay, let me do the licensing once again.
Yeah, that's better.
Yeah, it's a yellow colored thumb, na, usually. Let me do the licensing once again. Yeah, so usually, licensing sometimes getting error. So sometimes we have to do the licensing again. So these are the real-time problems. So we have to face. Oh, but again, password and username is not there, right? We require a keyboard. Okay. Okay. We don't have enough funds. There is a virtual keyboard is there, Bharat? There is option some virtual keyboard in the Raspberry Pi.
No,
You
for
know
that
that?
for that you have to install the command again.
Okay. So like for licensing, actually we have to do this thing, email. But okay, let me. I can do that one. Okay, wait. Just can you meanwhile you can ask the questions so participant will if they have any queries please engage with
Yes,
that.
yes.
So yeah, and meanwhile I will resolve this one. Okay, just a minute.
Yeah, just within that 5 minutes, if anyone have any doubts regarding that hardware connections or sensors or controllers, you can please ask your questions over here so that we can I can handle that questions. Voice is not there. My voice is not reaching.
Yeah, your voice is coming, Bharat. I think yeah.
Yeah, any
Okay,
questions? Any
so
questions regarding
in the
controllers?
chat you can see. Yeah, chat you can see that.
Yeah, I'm seeing that. Participant can ask any questions. Only pending thing here is that we have to send that values to the cloud. So that we are going to show in just 5 minutes. We'll just show you that because we already read that, seen that how to read the values and all. Just we'll send these values to the ThinkSpeak cloud. So that earlier we send this. I have shown you that how to open that ThinkSpeak and created the channels and fields. Okay, similarly that you can send the values to that particular cloud. Okay, any questions? Okay, so no questions.
Someone is telling again no voice. What is that?
No, I don't know. I think, so Naman sir, can you please respond whether our voice is reaching or not?
Your voice is quite audible, but your screen is not visible right now.
Screen is not visible right now?
Yes, sir.
So just a minute, sir. Okay. So if anything is missing, please inform us. Directly we'll react to that. Okay. So now I think you can able to see my screen.
Yes, right now it is visible, sir.
Okay. There's one question that what cloud will do with these values? Okay. What cloud will do this with these values? For example, now I'm reading the temperature and humidity values. So let us assume that I send these temperature and humidity values for the next 1 month or next 1 year. Let us assume that next 1 year I send all these values to the cloud. So after 1 year, what happened here using this temperature, humidity, and there is something called dew mobility. Dew point. There is something called dew point. So using all these things, we can form a database in the cloud so that whenever we want, we can download that particular data, whatever it is, we can download it. There is a one advantage. Second advantage is that without downloading, using that particular data, we can do analysis. We can apply some machine learning algorithms onto the particular data, and we can get what is the future temperature. So like if you calculate, if you are gathering last 1 year, what is the temperature you are gathering? After that, you can guess what will be the temperature for the next 1 month or next 2 months. You can guess the temperature values. So you can do a type of analysis using that particular data. So these analysis part, what are the algorithm application, machine learning algorithm application, all these parts will be done by the cloud. So what this controller is doing, it is just reading the values from the controller, and it is just processing it and sending it to the cloud. That is a part of controller. Okay, so using that cloud, we can do so much of analysis. So just example, I will show you last time that example for the ThinkSpeak. For example, here, this is my thing, smart environment here. So, okay, so here I have so much of apps. I want to do some plugins, a thing tweet, time control. I can do some reaction. Reaction means like whenever temperature is greater than this, I want to switch some information. I want to send some information to the people. So something like that, we can do all these analysis is going to be possible once the cloud have the information. If the cloud doesn't have the information, these are all applications are useless. Okay, so for that particular purpose, we have to send the